Welcome back. Now let us go the much more advanced of Arima, and that is called Arimax. X for generally it is stand for extra. So what is the extra? Before extra, let me explain the practical situation where you need this. Till now, you have been seeing that you have say a date time column and the actual value y, and this is what you have been keep on predicting it. And this y have been captured at the different time interval, and data which we are working that has been captured monthly. So each one is the month after month. This is the month after month, and this data is the month after month. Okay. But now see the share of any company. If you see that share of any company, let's take the example of say Apple. So Apple, the share price of Apple depends on lot of other things. It depends upon the macroeconomy, say macroeconomy, then political situation of the world, then how much, then what are the other things that depends, that revenue, P&L of the company, plus various, it could be other, say how the sales are going on, and so much. So if you see that the price of say share of Apple depends a lot of the other things, and you'll find that if you start doing analysis, probably you'll find 100 other things. So if you want to go ahead and use this information for your time series prediction, the time series forecasting, then how can you do it? This is what that extra thing you are going to use in X. That extra things will be using in X. Okay, so let's start. Line 216 is that line 216 is the, let us taking the data DCM of fresh, 217 converting to data table, 218 making the name to column name to uppercase, 219 let us see the data. So here we are trying to see the 20 data. And what we are going to work, this one we are going to take the dependent variable basically for which we will be working, and we are saying that 1 year outcome depends on these three also, that 3 years, 5 years and 10 years. Okay, so in our case of Arima, we'll take Arimax. We'll say this is our main data, main dependent which we want to forecast, and this is the three things that also impacts the 1 year outcome. Okay, so this is what, and line 221 list of the predictive names. So predictive names, if you see that these are the three as you're talking about, I'm trying to print it over here. So 3 years, 5 years and 10 years. Okay, good. Line 225 simply creation of MSTS object so that we can work, and similarly we can do the auto Arima the way it did. So let me do it first and then let me explain, because it takes time. So it is taking the first one is our object data, it is equal to true, so that you can see these kind of things, and yes, X-reg. See, this is where the extra data it comes. So if you remember, this is the predictive variable with 3 years, 5 years, 10 years, and this is the data, that is respective data. Okay, so this is the data it's all about. This is X-reg, take that extra amount of data. So this is also getting used this time in forecasting, and this is the bit more accurate than the Arima, because here we have using the extra data for the forecasting, and in case of Arima we had used only this part. Okay, and for like a trace stepwise and approximately, I'll request you to see the documentation. This is stepwise and approximately, please see the documentation, it's the easy definition. Okay, That's all. It will take some time. Since it is working with this much, so it generally takes time, and it is a bit slow. So that is why a word of caution. Let me explain. Suppose in case of your actual project, and you are using the Arimax, then when you go and do the auto Arima try to do during the weekend. So suppose you run on Friday and Monday morning you come, it will be ready. That is what you try to do, and see, it is no need to do it every time. Once you have done, continue to work with for the some time till the really there is a huge change in data. And actual productions, try to run it in once in a month or 3 month or 6 month. So it's not necessary you should be running it every day, because this to run itself takes almost 2 to 3 days. And the count you can say, see this combination is say around 50, and if your model itself is taking one iteration 1 hour, then 50 into 150 hours to take to build. That is why once you have run it, and so no need to run it every day, it will be good enough. And depending upon the, sometime it happens that you are getting huge amount of say error and all, then try to run it all together. Okay, so good. So it has already completed, and it has find it out 302 is the best model. Okay, good. Okay, now this is what, let us say 229. So these are the things. 3 means ER3, 0 is already nothing, 2, MA1 and MA2, and these are the coefficients of the 3 things which we are talking about. Okay, good. Now let us see whether it is uncorrelated nature or not. SCF. So yeah, it is uncorrelated only. I think at this around 7 or 8 there is some correlation, and around 15, 16 there is some correlation, and around 20 there is some correlation. It's okay, but not perfect, but it's okay, looks good. Box text. Let me show it over here. Okay, and box text, the P is less than 0.05. It means we do not have the data to accept the null hypothesis, and we have to reject it. So when you reject the null hypothesis, it means not independent. It means we still need to improve a bit. Okay, now let us see that actual and the predicted data. This fitted is the predicted. So 241. Let us see. So it looks good. If you see, it looks good. And here actual was in the red and blue. So mostly we see the almost blue is on top of the red. So it's looking good. And if you want to predict for the next 12 month, line 244 is the way, and you can see the production. This is the data. Okay, now let us see the predict part. It has gone. Okay, good. But why it has? Oh, okay, just a minute. See, oh, instead of it is not a 12 month. If you see that this train, how much data we have it. So we have 558, basically complete data. So this is the wrong prediction for next data. Just for practice, let us take the past data. So what I'm trying to say that let's assume that this itself, if you want to predict for the next, then you need to have those 3 and 5 year this outcome also. So for let's assume that next for this many month you have the 3 and 5 years in the similar as per the past. So that once you give this, and that is why you are getting 558 month, and that is approximately around 40 years or so. So because here we had this data around 1950 to 200, so 40 to 45 years, this is what it is starting. So if we have the similar things, this is what the prediction is. Okay, good. And this is just for easy manipulation and entry. 248 we are converting to data frame and dimension. If you see, this is our prediction and all. Okay, now this is the accuracy. This will print a map and tells you. And if you see that, if you I don't know if you recollect map how much it was for Arimax. Let me see if that data is still there. Yes, it was 4.66, and so 4.66 it has come down to 1.77. So it looks quite good. And Thales 0.37 has also come down from 0.93. 0.93. So that is much better. This is what is called the improvement. And Arimax generally gives the improvement, and it has to give because it is taking some extra data to give you the outcome. Okay, so that's all for this one. I think this is not required, this homework we have already done in the previous. That's all for Arimax. Thanks for watching it. See you in the next one.